Hello and welcome to day 4, looking at geometric series. The actual equation for a geometric series is S sub n equals the first term. This is the first term. The r being the ratio. So the first term multiplied by 1 minus the ratio raised to the number of terms you're adding up, all divided by 1 minus r. Please make sure when you're doing this in your calculator, you're using the alpha y equals fraction button. You're making it a fraction. If you do not have that button, make sure that you're using parentheses, especially around this 1 minus r. We are not going to use that formula. We're only going to use this first one. It's very straightforward. You need to have the first term, you need to have what you're multiplying by, you need to have the number of terms you're adding up, and that is it. It is much nicer and simpler than the arithmetic one. So if we look at the very first question, exercise number 3, which of the following represents the sum of a geometric series with 8 terms whose first term is 3 and the common ratio is 4? So all I'm going to do is I'm looking at how many terms, 8, so S sub 8 equals, the first term is 3, 1 minus r is 4, raised to the 8th, all divided by 1 minus 3. Now, I'm going to give you the answers. Please make sure that you know how to plug this into the calculator. This is going to equal 65,535, which is choice 5 there, which is choice 4. Exercise number 4, find the value of the geometric series below. Show the calculations that lead to the final answer. How do you go from 6 to 12, 12 to 24, and so on? Well, remember that you're going to do 12 divided by 6, and you would get 2. That's what our ratio is going to be. The next thing is, what is this nth term? So we're going to put it in the calculator. Our first term, 2, raised to the n minus 1. You put that in the calculator, and then you go to the table until you see 768. When you put this right here into the calculator, you will see that the 8th term is 768. So S sub 8 equals our first term 6, 1 minus 2 raised to the 8th, all divided by 1 minus 2. And that will give us 1,530. That is our answer. We're going to skip exercise 5 for right now. And we're going to go right into number 6. A person places 1 penny in a piggy bank on the first day of the month, 2 pennies on the second day, 4 pennies on the third day, and so on. Will this person be a millionaire by the end of the 31st day? What are we doing? We're going from 1 to 2, 2 to 4. How do we get that? Again, 4 divided by 2, you get 2. It is not adding 1 clearly because 2 to 4 is multiplying by 2, not adding 1. Sum of 31. What is our first term? 1. 1 minus 2 raised to the 31. All over 1 minus 2. Plug that in your calculator. You are going to get a large number. 21, 4, 7, 4, 8, 3, 6, 4, 7. Make sure it's in pennies, so we put a decimal point there. Count over 3, comma, count over 3, comma. So you would have $21,474,836.47. Will you be a millionaire? Most definitely. I'll take that money if anyone wants to do that. Moving on to check your understanding. Looking at A, if T1, if the first term is 8 and the difference is 3 in an arithmetic sequence, notice that we're looking at arithmetic. Find the sum of the terms through T of 10. Remember that arithmetic is n over 2, a1 plus an. What do we need? We have our first term. We do not have our 10th term, so we need to find the 10th term. T of 10 equals our first term, 8 plus 3 times 9 minus 1. T of 10 will give us 35. Now, finding the summation of our 10th term, we will get 10 divided by 2 times 8 plus 35. And yes, I'm cheating, I'm using my notes. We're going to get 215. Not that good with math in my head. That's for arithmetic, again, needing the first and the last term. Looking at B, we have t sub 0, that's key. T sub 0 equals 1 and r equals 2.5. Find the sum of the terms up through t12, the 12th term, and it's a geometric. Remember that our geometric formula is a1, 1 minus r to the n, all over 1 minus r. We are given t sub 0. We need to find t sub 1. And t sub 1 is 1 times 2.5, and we'll just have 2.5. All we need to do now is plug in, so the summation of 12 terms is a1, 2.5, parentheses 1 minus 2.5 raised to the 12, all divided by 1 minus 2.5, and that will give you 99,339.41. And if any of you would like to check my math, please do so and let me know if I'm wrong in class. C, find the sum of the first 15 terms. Looking at the first chart, how do we go from 2 to 6, 6 to 18? Well, our ratio is 3. All we are going to do is S of 15 equals our first term 2, 1 minus 3 raised to the 15, all over 1 minus 3. Plug it in your calculator. Take the time to do it. Pause it if you need to. Make sure you get the correct answer. 1,434,890,6. So 14,348,906. We're going to skip the next table. Go right to D. A popular shoe store sold 5,700 pairs of athletic shoes in 2008. Projections are for a 3% increase in sales each year for several years after 2008. What is the projected total sales? So the projected number of athletic shoes sold from 2008 to 2015. The 3% increase is the key here. What's the ratio for a 3% increase? 1.03, or 1 plus 0.03. That is our ratio. One of the things that we need to look at is from 2008 to 2015, A1 is implying that we're in year 2008, so 2009 would be year 2, 10 year 3, 11, 12, 13, 14, 15. So we're going to be in year 8. Summation of then 8 years equals our first year, which was 5,700 pairs of shoes. That's why I did not put equals. I just said it implies the year 2008. 1 minus 1.03 raised to the 8, all over 1 minus 1.03. And we are looking at 50,686 pairs of shoes approximately. There's a decimal point in there, so we'll say approximately there. Moving on to the last part that we'll do, let's go all the way down to I on the last page of the notes. Once a week, Mrs. Baker makes sugar cookies. The first week she makes a recipe with 2 full cups of sugar, so it makes the cookies good. Each week after that, she reduces the amount of sugar by 1/3. It won't be sugar cookies for long. If she reduces it by 1/3, your ratio is 1 minus 1/3, or 2/3. There's 2/3 of the sugar left. How much sugar does she use for the cookies on the 5th week? She used 2 to begin with. 2/3 is your ratio, the 1 minus 1/3 raised to the 5th. And that equals, turn the page, 0.263 cups of sugar, or 64 over 243. Telling you, not a good thing. Use more sugar. How much sugar in total does she use for cookies in a 6-month period? Notice that we're in weeks. So 6 months, we'll say, is 24 weeks. So how much total sugar does she use? Well, again, we'll use a summation formula. First term, 2, 1 minus 2/3 raised to the 24, to 24, all over 1 minus 2/3. Again, use your calculator, use the fraction button. Don't make a mistake here. Maybe like I am going to, but I'm going to say that's approximately 6 cups. Someone should probably check me on that. 6 cups, it was 5.999, so we just rounded to 6. The last one, and maybe one of the most important ones, in a geometric series, the third term is 8, the 7th term is 648. Find the sum of the first 7 terms. Well, what don't we have? A, we don't have our ratio, and we don't have our A1 term. Everything needed to find the summation of that. So what do? Well, we go back to how do we find R? And we talked about this at the end of 2 videos ago. You have the 2 terms, A7 over A3 being divided equals R to the 7 minus 3. What is A7? 648 divided by 8 equals R to the 4th. 648 divided by 8 is 81. Equals R to the 4th. And when you have anything raised that we're trying to get rid of, we will raise it to the reciprocal of 1/4. And R will equal 3. So R equals 3. Now we use our formula, our generic formula, to find A1. Again, I'm going to use our 8 and our third term being 8, not the 648, it's just smaller numbers. So 8 equals A1, parentheses 3 to the n minus 1, or 3 minus 1. So 8 equals A1 to the times 9, divided by 9. A equals 8/9 here. Now, all I'm going to do is plug in our first term for our summation. 1 minus 3 raised to the 7, all over 1 minus 3. And that gives us 971.55 repeating. And as I said, I don't like the repeating symbol. Let's write it as a fraction of 8,744 over 9. And with that, enjoy the day, and I will see you in class. Only one more day to go for this unit. Have a good one.